May the force be with you. Hey guys, welcome back. It's Medicosis Perfectionalis. This is my physics playlist. In previous videos, we have talked about scalars versus vectors, distance versus displacement, speed versus velocity. We talked about physical quantities, measuring tools, and measuring units. And we talked about acceleration as well. Today, we shall talk about force. What is the definition of force? To understand the definition, imagine that you're pushing a truck or a car or a box. Force is an external influence that affects the object to change its state of motion or direction. The car engine has a force that pushes the car forwards. The brakes have force so that when you apply the brakes, you force the car to stop. When the rubber hits the road, there is friction between the tires and the asphalt or the concrete. Gravity is a force that is always trying to bring you down. Your weight depends on gravity. But since every action has an opposite and equal reaction, there is another force that is trying to lift you up. We call this the normal force. And if this were an airplane, the force that tries to bring you down is the weight of the airplane. The force that is trying to lift you up is called, guess what? Lift force. The thrust of the engine of the airplane pushes you forwards, but the resistance of the air is trying to push you backwards. What do you think? Was this a great introduction about force? Or is Bernoulli rolling in his grave right now? Force is measured in newtons. Thank you, little Isaac. Now click the like button, click the subscribe button, and let's get started. This video is part of my physics playlist. Try to watch these videos in order for maximum understanding and retention, not to be confused with mechanical retention or with my patient's urinary retention. Check all of these playlists as well. Back to basics. Physical quantities are divided into fundamental quantities and derived physical quantities. Why do we call them derived? Because we derive them from the fundamentals. As for the fundamentals, they cannot be derived from anything else. They are the physical equivalents of philosophical primaries, so to speak. I am too sophisticated to the point of being stupid. What are the fundamental physical quantities? Length, time, luminous intensity, amount of material, electric current intensity, distance, temperature, mass. What are the derived physical quantities? Surface area. It is derived from length times width. How about volume? It is derived from length times width times height. Measuring unit, meters, square meters, cubic meters. Speed is derived from distance over time. Velocity is derived from displacement over time. Acceleration is derived from velocity over time. And force, which is derived from mass and acceleration. F equals m times a. If you want a horrible mnemonic, just write F equals MA and just imagine that I'm insulting your mother. How dare you, Medicosis? Easy, easy. We measure length in meters, time in seconds, temperature in Kelvin, mass in kilograms, amount of substance, moles, electric current, amperes or amperes, light intensity, candela. These are the 7 fundamental quantities or SI base units. Speed is derived from distance over time. That's why speed is measured in meters per second. As for force, again, it equals mass times acceleration. Mass is measured in kilograms, and acceleration is measured in meters per second or meters per second squared. So we measure force in kilograms times meter per second squared. Or you can just call it Newton. This is Newton. 1 kilogram times meters per second equals 1 Newton. Scalars versus vectors. What is a scalar? It's a physical quantity that has a magnitude only but no direction. How about vectors? Physical quantities that have both a magnitude and a direction. Distance is a scalar, but displacement is a vector. Speed is a scalar, but velocity is a vector. Mass is a scalar, But weight is a vector because weight is dependent on gravity, which is always trying to pull you downwards towards the center of the earth. So it has a direction. Today we're talking about force. Force is a vector. It does have a direction. And remember, force equals mass times acceleration. Where is mass? Mass is here. Mass is a scalar and acceleration is a vector. Whenever you multiply a scalar by a vector, you get a vector. What is the definition of force? It's an external influence that affects the object, let's say a box, to change its state of motion or direction. So I am applying force on that box. How do we measure speed? Speedometer. How do we measure time? A watch. How do we measure length? A measuring tape. But how do we measure force? Spring balance. That's the measuring tool. But what's the measuring unit? Newton. 1 Newton is equivalent to what? It is equivalent to 1 kilograms times meter per second square. Why is this? Because force equals mass times acceleration. Mass is measured in kilograms, acceleration in meters per second squared. That's it. The abbreviation of Newton is N. Do you remember this question that we have discussed before? Please pause and try to answer this yourself. Okie dokie, we have a vector, and this vector is a force. We know that because force is a vector of 100 newtons at 30 degrees above the x-axis. When in doubt, draw it out. Here is the x-axis and here is 30 degrees with the x-axis. So this angle is 30 degrees. We'll call it theta. And this force equals 100 Newton in magnitude. Here is the magnitude of the force and here is the direction of the force. Each vector can be split into its two components. And there will always be a horizontal component, we call this x, and a vertical component, and we call that y. How can we find fx and fy? You remember the rule, right? Fx, it has a q sound, equals f cosine theta. Amazing. How do you find the y component? Remember the mnemonic. Fy is f times si, sine theta. The y with the I. Let's start with the fx. What is f? 100 newtons multiplied by cosine 30. Cosine 30 is square root 3 over 2, or half of square root 3. Multiply these two doofuses together and you get about 86.61 newtons. This is the x component. As for the y component, it is f times sine theta. F is 100 newton. And sine theta is sine 30. Sine 30 is 1/2. So it is 100 times half equals 50 Newton. So here is your x component and your y component. All of this is to tell you that force is a vector. It has a magnitude and a direction. Let's suppose that we have a big truck and a small car. They are driving in the opposite direction and they will collide in the midline. And let's suppose that both of them were driving at the same speed, about 100 kilometers per hour. After collision, which one will push the other one? Well, since the truck has a higher momentum, the truck will push the car in this direction. Momentum, what is momentum? Momentum is the mass times velocity. There is momentum for the truck and momentum for the car. We have agreed that both of them were driving at the same velocity, so this v equals that v. However, the mass of the truck is huge, but the mass of that small car is less. Momentum is directly proportional to mass. So, the higher the mass, the greater the momentum. And the lower the mass, the lesser the momentum. Momentum is directly proportional to mass. Momentum is directly proportional to velocity, but mass and velocity are inversely correlated as long as momentum remains constant. Now let's suppose that we pushed the truck and the car with the same force. The same force is applied to both a large and a small object. By the way, pushing force is also known as applied force. It is the force of pushing. Opposite of that is the force of pulling, known as, you guessed it, pulling force. So the pushing force for the truck is the same pushing force for the small car. When I push this and this with the same force, which one will accelerate more? Of course, the tiny car will accelerate more than the big doofus truck, which means the larger the object, bigger mass, the less the acceleration. Oh, so the relation between mass and acceleration is inverse, exactly, because they are multiplied by one another. If you want to learn how to determine the direct versus inverse relation, please watch my first video in this playlist titled Introduction to Physics. The greater the mass, the lower the acceleration, provided that the force remains constant, which is true because this force equals that force, which means the mass and acceleration will be inversely proportional. The truck has a larger mass, and that's why it accelerates less rapidly. Conversely, the small car has a smaller mass, but greater acceleration. You can download these wonderful, colorful notes at medicosisperfectionalis.com. I help you learn, understand, and pass exams. Now, what if the force was not equal? Here is small force and here is a bigger force. But they are pushing the same car, or let's say two cars that are identical. They have the same mass. Which car will accelerate more? Of course, the one exposed to a greater force. I mean, think about it. The relation between force and acceleration is direct. When force goes up, acceleration goes up. Conversely, when force goes down, acceleration goes down. This one has a greater force, and that's why it will accelerate more. Now, if you are mathematically sophisticated, you will recall that acceleration equals what? Well, acceleration equals delta v over delta t, or acceleration is the rate of change in velocity. The rate of change of distance is called speed. The rate of change of displacement is called velocity. And the rate of change of velocity is called acceleration. That was clean. So force equals mass times acceleration, and acceleration is velocity over time. Therefore, we can put velocity over time in place of acceleration. So force equals mass, leave it alone, multiply that by delta v over delta t, and this is a new equation. There are many types of forces, as we have discussed in video number 1. We have contact forces and non-contact forces. Contact forces include pulling force if you're pulling towards you, pushing force, also known as applied force if you are pushing to the other side away from you, frictional force, such as friction between the tires of the car and the road. Normal reaction force, what's that? Remember the book on the table? Let's draw the book. Beautiful. On the table. Okay, gravity is trying to pull you downwards. However, there is an opposite normal reaction force trying to lift you up. The reason why the book stays stable on the desk is because this force equals that force. They are equal in magnitude, but they have opposite directions, proving once again that force is a vector. It has a magnitude and a direction. One of the contact forces is spring force. That was the first type of forces, contact forces. We also have another type, non-contact forces, including gravitational force trying to bring you down, electrostatic force, magnetic force, and nuclear force. To appreciate the presence of electrostatic force, get a pencil, rub the pencil against your hair. Do not rub the graphite part, rub the wood against your hair for a long time, and then make that pencil touch a tiny piece of paper. You will find out that this tiny piece of paper is attracted to the pencil. Magnetic force, magnet, North Pole, South Pole, you know the story, and nuclear force. Again, force equals mass times acceleration. Mass is measured in kilograms, acceleration is measured in meters per second, or meters per second squared. Why is that? Because this acceleration equals delta v over delta t. How do you measure delta v? In meters per second. How do you measure time? In second. You can bring the s downstairs, making this meters per second, or meters per second squared. This is it. So how do I measure force? What's the measuring unit? You can say kilograms times meter per second squared, or simply Newton. And if you remember video number 2, it was the video when we talked about all of this. Surface area is length times width. Volume is length times width times height. Density is mass over volume. Speed is distance over time. Velocity is displacement over time. Acceleration is velocity over time. Momentum, P equals mv. Momentum equals mass times velocity. Force equals mass times acceleration. You see that force? When we multiply it by displacement, you get work. And pressure is force over area. This is very important when you later study biology and physiology and pharmacology and internal medicine and surgery. Let's review Newton's laws of motion quickly. Every time I think of Newton's laws of motion, I always recall the lyrics of the crazy song, "Come on, do the locomotion with me." What people did not understand that this was a song about accelerations and gyrations. So what did Newton's first law of motion say? A static object remains static, okay? And a moving object keeps moving at a uniform velocity in a straight line, unless acted upon by a resultant force. And when you add up all of these forces together, you end up with 0. How's that? Because remember, some forces have positive sign, others have a negative sign. But when you sum them up, when you give me the sigma, not smegma, of the forces, you end up with nothing. All of the forces will balance themselves out. So even though every individual force is not 0, the total of them, the totality of them is 0. So let's say that we had 4 forces, F1 plus F2 plus F3 plus F4 equals 0. Simply stated, sigma F equals 0. F means. Example, let's say that you put a book on the table. This book will remain at rest. It will remain stationary unless somebody acts to affect it and change its state. A clear application of Newton's first law is friction, which we'll talk about in a separate video in this physics playlist. The first law could be also called the law of inertia. What is inertia? It is the property of the object to resist the change of its static or dynamic state. For example, suppose that you were driving your car at a speed of 50 kilometers per hour. And because you're a horrible person that drives recklessly, you ended up hitting a tree. The moment your car hits the tree, your body will keep moving forwards. If you were wearing a seatbelt, and this were a good car and not a Chevrolet, the airbags would deploy and prevent you from flying out of the windshield. However, if you were not wearing your seatbelt, or your car was a Chevy, or God help you, a Chrysler, you will end up flying through the windshield. Why did I keep moving? Because of inertia. Because you were in a dynamic state as long as you're driving your car. So you are dynamic, you are in motion, you're in motion. When the car stops suddenly, you resist any change to your motion state, so you keep moving. So inertia is the tendency of an object to keep either its state of rest or state of motion. Basically, inertia means the status quo. Of course, I have nothing against Chevrolet or Chrysler. I was joking. Now, let's say that you are driving at 50 kilometers per hour. You will fly through the windshield. But let's say that you are driving at 100 kilometers per hour. You will fly faster. It will be harder to stop you. You will keep moving faster. Another example, if you are in a car and the car is at rest and you will start driving. When you slam the gas pedal or the accelerator, the car will speed up quickly, but your body will lean backwards. Why? Because your body was static and it wants to remain static. It wants to resist any change. So you'll swing backwards as you start your car. But when you brake, suddenly the opposite happens. You will keep moving forwards. By the way, sudden severe deceleration of your car, even if your car did not hit anything, can actually tear your aorta. Because there is a part of the aorta that is particularly vulnerable to deceleration injury. Next, the second law of motion of Isaac. Quote, the resultant force affecting an object equals the rate of change in the object's momentum, which is m times v, or mass times velocity, over time. Remember that anytime you say the rate of, you imply that there is time in the denominator. And that's why speed is the rate of change in distance. The rate of change of distance, and velocity is the rate of change in displacement, and acceleration is the rate time of change in velocity, and force is the rate of change in momentum. That was beautimous. And if you are mathematically sophisticated, you will notice that this momentum is the same as this momentum. Momentum is mass times velocity. So we can remove momentum and put mass times velocity, and here's an equation for you. We can perform cross multiplication. Mass times velocity times 1, which is nothing, equals force times time. Also, if you are mathematically sophisticated, you will notice that V over T is what? It is acceleration. So F equals mass times acceleration. Bingo. And this is the mathematical equation or formula for the second law. If force equals mass times acceleration, then 1 Newton equals 1 kilogram times meter per second squared. That's why we can define 1 Newton as it is the force that when acts upon an object whose mass is 1 kilogram, it accelerates at 1 meters per second squared. In the same direction. You gotta say in the same direction because force is a vector. Third, Newton's third law of motion. For every action, there is an equal but opposite reaction. Equal in magnitude, but opposite in direction. Suppose that I was trying to push the wall, okay? I am pushing against the wall, and the wall is pushing against me. I am pushing to the right, the wall is pushing to the left. Let's say that I am pushing with a force of 5 newtons. The wall will respond with a force of 5 newtons. They have the same magnitude, but opposite direction. So what's the mathematical formula? F equals negative F. One is going this way, the other is going that way. Hence the negative sign. Negative here means in the opposite direction. From the first law, we can deduce that as the mass goes up, what do you think is gonna happen to momentum? Momentum goes up, and inertia goes up. Think of inertia and momentum as two sides to the same coin. If inertia goes up, what's going to happen to the force required to accelerate that object? It increases. For example, let's say that we have a stationary car and a stationary truck. Of course, the truck is bigger. So the truck has a bigger inertia because it has a bigger mass, which means the truck requires a bigger force to accelerate it. Put differently, the truck requires more energy in order to speed up compared to the small car, of course. Conversely, the truck requires a greater force to make it stop while moving compared to a small car. That's why you always respect the kings of the road, the truckers. Don't be stupid and maneuver your little car in front of the truck suddenly. Do not play games with objects that can flatten you. You cannot break the laws of physics. If I have decided to break the law of gravity by jumping off the window, I will break my neck and prove the law of gravity. And if I broke my neck completely, like a complete transaction of the spinal cord, I'll get quadriplegia. And if the transaction is high enough near my brainstem, I'll die. Because remember that the medulla oblongata of your brain in the brainstem contains the cardiovascular center and the respiratory center. So say goodbye to my heart and my lungs, which means medicosis is officially toast. And you will be stuck with your crazy professor with his PowerPoint. So force equals mass times acceleration. If they give you a problem and force is the unknown, so I know the mass, I know the acceleration, but force is the unknown. Put your finger on force, hide force, and then look what's remaining. Mass times acceleration. So you multiply both of them together. But let's say that acceleration is the unknown. Hide it with your finger. Then what should I do? F over m. Force over mass to get acceleration. What if mass is the unknown? Hide it with your finger. Force divided by acceleration will give you the mass of the object. The rate of change of distance is speed. The rate of change of displacement is velocity. The rate of change of velocity is acceleration. And the rate of change of momentum is force. Thank you, Isaac. Question time. Here is a problem for you. Calculate the momentum of an object whose mass is 10 kilograms that covers a displacement of 20 meters in 4 seconds. Please pause and try to solve this yourself. What do they want? They want momentum, and momentum equals mass times velocity. Do I have the mass? Yes, indeed, the mass is 10 kilogram. This is what I know. What else do I know? Do I have the velocity? I do not have the velocity. However, I have displacement, which is 20, and time, which is 4. From displacement and time, can I try to find velocity? Absolutely. Velocity equals displacement over time. Displacement is 20 meters and time is 4 seconds. 20 divided by 4 is 5 meters per second. And this is my velocity, so this goes here. So momentum equals mass, or 10 kilograms, multiplied by velocity, or 5 meters per second. 10 times 5 is 50 kilograms times meter per second. And here is the same answer in color. Mass is in kilograms, velocity in meters per second. Therefore, momentum is measured in kilograms times meters per second. Another question. What does the slope of this green line represent? Does it represent velocity, mass, momentum, 1 over mass, or 1 over time? Knowing that A is the acceleration and F means force. Please pause and try to answer this yourself. Acceleration and force. Do I have any equation that links these two together? Yes, I know that force equals mass times acceleration. Beautiful. How do I get the slope of this green line? Any slope equals delta y over delta x, the change on the y-axis over the change on the x-axis. In other words, it's rise over run. So what is the rise? The rise is the change in acceleration. And what is the run? The run is the change in force. Okay. Can I rearrange this equation to make area over force? Yes, of course. Let's divide each side of the equation by force. This becomes 1 and this becomes mass times area over force. But I want area over force alone. Therefore, divide each side of the equation by mass. On this side, you have 1 over mass, and on the other side, you have acceleration over force. Is this what I want? Yes, I wanted acceleration over force. The slope equals acceleration over force. And acceleration over force is what? It is 1 over mass, making choice D the correct answer. If you're mathematically sophisticated, you can look at this equation. What do I want? I want acceleration over force. So acceleration over force, look where are you going? I'm going this side. Acceleration over force equals whatever is here over mass. This force is multiplied by 1, so it is 1 over mass. A over F is 1 over M. What if I want F over M? F over M is A divided by 1, or A. What if I want force over acceleration? F divided by A equals M divided by 1, or simply M. F over A equals M, but A over F is 1 over M. Next, if the object's mass decreased to half of its original value and the resultant force doubled, what's going to happen to the acquired acceleration? Will it double, quadruple, halve, becomes a quarter of its original value, or stay the same? Please pause and try to answer this yourself. Okay, how can we answer this? All right, just let's write the equation. I know that force equals mass times acceleration. They wanted to know what's going to happen to acceleration. So I want acceleration on one side. By dividing each side by mass, you get acceleration equals force over mass. Okay, this is the equation that I will play with. First, what happened? The mass decreased by half. The relation between area and mass, one is up, one is down, is inverse. As mass decreased to 1/2, the acceleration should double. And this is point number 1. Point number 2 is the force doubled, upstairs and upstairs. The relation between acceleration and force is direct, which means if force doubles, then acceleration will double. And this is point number 2. So from point number 1, acceleration should double. And from point number 2, acceleration should double. Double and double. Oh, 2 times 2 is what? Is 4. So acceleration will quadruple. There is another way of doing this. Here is the equation. Rearranges so that acceleration is on one side alone. It's force over m, mass. Okay, so let's assume that A1 before any changes was F1 over M1. Okay, then what happened? The mass decreased by half. So instead of writing M1, I will write half of M1. And what happened to the force? It doubled. Instead of writing F1, I will write twice F1. Okay, 2 divided by half is what? You bring this 2 upstairs, it is 4 divided by 1. Oh, so A2 is 4 times greater than A1. So the correct answer is quadruple, baby. Coming up next, a car of mass of 1,000 kilograms moved from rest to acquire a velocity of 20 meters per second after a time period of 5 seconds. Calculate the pushing force, also known as applied force, assuming no friction whatsoever. Please pause and try to solve this yourself. Okay, let's start by writing down what I already know. They told me that the mass is 1,000 kilograms. Amazing. They told me that we started from rest. So let's say that V initial or V0 equals 0. And what is the final velocity? 20 meters per second. Amazing. And then what else do I know? The time is 5 seconds. Okay, what do they want? They want the force. Oh, do I have an equation for force? Yes. Force equals mass times acceleration. Do I have the mass? Yes, I do. Do I have acceleration? I do not, but they gave me velocity and time. Amazing. So here is acceleration equals delta V over delta T. What's the change in velocity? It's the difference between final and initial. It is 20 minus 0, or simply 20 meters per second. And what is time? 5 seconds right here. 20 divided by 5 is 4 meters per second, or meters per second squared. This is my acceleration. So force equals, what's the mass? 1,000 kilograms. And what's the acceleration? 4 meters per second. 1,000 times 4 is 4,000 kilograms times meter per second squared. And remember that kilograms times meter per second squared is the same exact thing as Newton. So the pushing force is 4,000 Newton, and this is my final answer. Here's the same answer in more color. Pause and review. Next, let's solve the problem that we talked about in a previous video. A tiger started running when it saw a deer running at a constant velocity of 2 meters per second at 15 meters far from it. If that tiger ran at an acceleration of 2 meters per second, when and where will the tiger catch the deer? Please pause. I'll be so proud of you if you can solve this correctly. So first, you take a deep breath and you write down what we already know. They told me that the tiger started running. Oh, so it was resting, which means for the tiger, velocity initial, or the initial velocity, or V0 or VI equals 0. And then what's the final velocity? They did not tell me the final velocity of the tiger, but they did tell me about its acceleration. And what's the acceleration for the tiger? It is 2 meters per second squared. And this is everything that I know about the tiger. Okay, what do I know about the deer in the headlight? It is running at a constant velocity of 2 meters per second. Okay. And then they told me about the distance between the tiger and the deer. So let me draw the tiger. Okay, here is the tiger. And let me draw the deer in a red color. Okay, here is the deer. Okay, beautiful horns. Amazing. What is the distance between the tiger and the deer? 15 meters. Let me write that down. From here to here, we have 15 meters. Okay, let's call this small d, or D1. The problem says that the tiger will eventually catch the deer. So we'll suppose that the tiger will catch the deer at this point. And let's call the distance between the deer right now and where the tiger will catch the deer, let's call that distance D2. Okay. Now, what is the distance that they want? They wanted not D1 and not D2. They wanted D1 plus D2 from beginning to the end of the chase. That is the where question. Now, how is the when? The when is the time that it took the tiger to catch the deer right here. So here's an important fact. The time that takes the tiger to reach this point is the same time that takes the deer to reach that point. T for the tiger is the same as T for the deer. So let's write a T here and a T there. Now, what is the distance that the deer will run? Only D2. And what's the distance that the tiger will run? D1 plus D2. Let's call D1 plus D2 something different. Let's call this big D, uppercase D. And we know that this uppercase D equals what? It equals 15 plus D2. Now, here is an easy equation for the deer that we can get out of the way. I know the velocity is 2 meters per second, and I know that velocity, which in this case is 2, equals distance, let's call that D2, over time, all right? Which means that D2 equals 2 multiplied by T, cross multiplication. Okay, so if I can find out How much is t, which is the same for the tiger and the deer? And this answers the when question. I can then find d2 because d2 is twice the time. Then I can get that d2 added to d1 to get the total distance for the tiger, and this answers the where question. So from the tiger's perspective, I know v0, I know acceleration, I do not know t. So which equations should I use? If you have watched my previous video titled Equations of Motion, Kinematics in One Dimension, we have talked about these famous three equations before. I want an equation that can capture the when and the where. Oh, let's use this equation. This is the equation that we'll use. Since the tiger started from rest, all of this is 0, so we can modify the equation into distance or displacement equals half a t squared. So here is d equals half a times t squared. T is unknown. Do I know d for the tiger? If you said, oh yes, it is 15, no, that's a big mistake. I do not want to solve the equation between the tiger and the deer. I want it from the tiger's position right now to wherever the tiger catches the deer. Oh, so it's not this. It is this plus this. That's your d that you're looking for. So let's change this from lowercase d to uppercase d. What is uppercase d? It is d1 plus d2, or simply 15 plus d2. So let's write this down. 15 plus d2 equals half. Do I know acceleration for the tiger? Yes, it is 2. Do I know t? This is the unknown. To simplify, this is d2 plus 15 equals half times 2 is just 1t squared. Do I know anything about this? Yes. You see this d2? Yeah, d2 equals what? 2t. Oh, amazing. I can put this here. So 2t plus 15 equals t squared. Let's rearrange the equation to make it look like this. T squared minus 2t minus 15 equals 0. And then you know from classic algebra, it looks like this. Here is t, here is t. Since this number here is a negative, therefore one of them has to be positive and the other has to be negative. Which number should I use here? Well, numbers whose product will give me 15. And when you multiply by the t's, you get a difference of negative 2t. How about 3 and 5? Yes, indeed. In order to make this negative, let's put the 3 here with the positive and the 5 here with the negative. Amazing. Which means negative 5t plus 3t equals negative 2t. Amazing. And t times t is t squared. Amazing. Positive times negative is negative. Cool. 3 times 5 is 15. Yay. So this means one of two things. Either t plus 3 equals 0 or t minus 5 equals 0. If t plus 3 equals 0, t equals negative 3. Time is negative. That's impossible. So this is nonsensical. Let's focus on this. T minus 5 is 0, which means t alone is 5 seconds. And this is the answer of the first part. When will the tiger catch the deer? After 5 seconds. Wow, that's a fast tiger. If I know t, which is the same time for the tiger and the deer, it's the time that took the tiger to catch the deer here. Can I know the total uppercase D? Yes. First, let me find out d2. I know that d2 is twice t, which means d2 equals twice the 5 or 10 meters. This is d2. Is this the final distance? No, I want the big D. Uppercase D equals d1 plus d2 equals 15 plus 10 or 25 meters. So the final answer for the time is 5 seconds. And for the distance is 25 meters from wherever the tiger started. And that was an excellent question. Here is the same answer in color, but here I tried something different. Here is the tiger. I wrote everything that I knew about the tiger here and about the deer there. Then I said that D for the tiger, all of this distance, is 15 plus this D. And 15 plus this D went here under the D, equals half of the acceleration t squared. And then I did not just say t squared. I know that the time is this D over 2. So I put it here. And now instead of solving for t, I did solve for D. I know that D is 10 meters, this distance, which means t has to be half of this, or 5 seconds. So that's the first part. And what's the total d for the tiger? It is 15 plus 10 or 25 meters. Let's answer this question that we have discussed before. Which of the following graphs represents a freely falling object? Is it A, B, C, or D? Please pause and try to think about it. Okay, free falling means what? Here is the balcony. All right, nice. And I will throw the apple. Here's the apple. The apple starts here. What is the initial velocity for this apple? V initial or V0 equals 0. It started from rest. And then it will descend and descend and descend. Who is pulling it downstairs like this? Gravity. And gravity has an acceleration of 9.8 meters per second, right? Yeah. Is this a positive number or a negative number? Well, you are speeding up as you fall. So this is a positive number. So positive 9.8 meters per second. So wherever I start, my velocity has to be 0 at rest. That's the beginning. How about the distance at rest? Still 0 meters because I have not descended yet. So look at this. I have distance over time, distance over time, distance over time, distance over time. Yeah, it's not time, it's time squared, etc. I don't care. What is distance or displacement over time squared? How can I find the slope? Remember that d equals VIT, but since I started from rest, you can erase this because this is 0, plus half AT squared. Let's divide each side by t squared. So d over t squared, which is what I want, the slope equals what? Half of a. So the slope of this line equals half of a. How about the slope of this curved line? Half of a. How about the slope of this? Well, it's not half of a, but it's something close. It has to do with acceleration. How about this? The slope is half of a. All right, so which one should I choose? Well, which one started from rest? This one did not start from rest, so that's impossible. Moreover, this acceleration is going downstairs, i.e. decelerating, and this is impossible. If I'm in a free fall, I am accelerating, so A is still not true. How about here? Well, I'm speeding up, but non-uniformly, which is nonsensical because gravity is a uniform acceleration, so B is impossible. How about C? Well, it's going up. It is accelerating, so this part is true. However, did I start from rest? Did I start from 0? No, I did not start from 0. I started from a positive number, which makes C impossible. How about D? Well, if half of acceleration is a straight line, then acceleration will be a straight line. Straight line going up, meaning that you're accelerating, that's true. Did you start from rest? Yes, I started from this 0 right here, making D the correct answer. So when you look at this problem, think about two things. Free fall means what? I started from rest, and the acceleration has to be uniform, i.e. constant, and positive, meaning I am accelerating and not decelerating. Is this V0? No, cancel it. Is this V0? No, cancel it. Then I'm stuck between this and this, the curved line and the straight line. Well, gravity has to be uniform acceleration. So this curved line is an exponential relationship, not linear. I want something linear, meaning uniform, making D the correct answer. So please bring a sheet of paper and doodle with Medicosis. What are the equations that we learned about today? From the first law of motion of Newton, the sigma for all the forces have to reach equilibrium, i.e. 0. F1 plus F2 plus 3, etc., has to equal 0 at the end. The positives and the negatives will cancel each other out. What was momentum? Momentum equals mass times velocity. Mass is in kilograms, velocity is in meters per second, so we measure momentum in kilogram times meters per second. Next, Newton's second law of motion. Force equals mass times acceleration. Where did you get that from? Well, force is the rate of change, meaning delta t, of momentum. Momentum is here. And what is momentum? We just talked about it. Momentum is mass times velocity over delta t. Okay, what is delta v over delta t? This is acceleration. So force equals mass times acceleration. This right here is acceleration multiplied by mass will give me the force. May the force be with you. Mass is measured in kilograms. Acceleration is measured in meters per second. Okay, so force is measured in kilograms times meter per second squared, or simply newtons. Then Newton's third law of motion, F equals negative F. This is going in this direction, this is going in the other direction. Same magnitude, F, but opposite direction. One is to the right, the other is to the left. One is positive, one is negative. So I've talked about force a lot. If you take that force, you multiply it by displacement, what do you get? You get work. So if the first important equation was an insult to your mother, the second important equation tells you that if you're fed up, then it's time to work and study. You can download my physics notes, general chemistry notes, biochemistry notes, organic chemistry notes, physiology notes, anatomy notes, all kinds of notes at medicosisperfectionalis.com. I help you learn, understand, and pass exams. Thank you for watching my physics playlist. Don't forget to check out my other playlists. If you found my videos helpful, please consider supporting my channel by buying me a coffee at buymeacoffee.com/medicosis. To learn about how your kidney functions, renal physiology, GFR, what happens in the proximal tubule, loop of Henle, distal tubule, collecting ducts, etc., download my kidney physiology course at medicosisperfectionalis.com. My courses come with videos, notes, and cases, with answers, of course. There are more than 600 premium videos available on this channel when you click the join button and choose the highest tier. Please subscribe, hit the bell, smash like, support my channel on Patreon, PayPal, or Venmo. Go to my website to download my courses, notes, and cases, or if you would like me to personally tutor you. Be safe, stay happy, study hard. This is Medicosis Perfectionalis, where medicine makes perfect sense.